Swayam Prabha. Digital India. Educated India.
Good morning students. So, we are in the module 2 of the course Fire Safety in Buildings. So, in the previous class or the previous module, we had discussed the basics or the basic items or contents what the syllabus will contain, and we had entered into the introduction part and how fire in a building is experienced. So, there we had learnt the fire load, how to calculate it, and based on that we had seen the different categories of buildings that our National Building Code 2016 defines. And from there we also learned that in certain kinds of buildings we have to take sanctions for our trade, that is what is mostly we are architects. So, in this module what are we going to learn about? As we had got the introduction to fire and how it behaves within a building, what is fire load and exposure to it, what can happen, the convection, conduction, convection and radiation parts. Now, we would like to understand the standard fire tests, because whenever we want to handle any material, we have to look into how it behaves against a fire. So, when we are designing the envelope as architects, we have to understand what material selection is important. This module is dedicated for the fire properties of materials, fire behavior of the materials, polymers and fire, because in today's context we have shifted from basic or regular building materials to gradually shifting towards use of plastics, use of metals, use of exposed facades in buildings, and they are actually subject to fire. If they are actually subject to fire, its behavior has to be known. So, very well established is the standard fire test, which we actually use when we compare a material against a standard fire test. There are various indices to measure to, and that will be discussed also in this module. So, let us see what is a standard fire test talking about. If you see this curve, you see on one direction it is the time, which is in minutes. Remember, the unit is minutes. On the other side it is temperature, which is in degrees centigrades. And if you see here at 800 degrees centigrade, you see there is a sudden change and the curve pattern of the curve and it changes. We had understood in the previous module what is a flashover. So, this indicates that flashover part, and when it is increased to a certain temperature, gradually it is having a steady curve, this very steady in nature, as you can see. But if you actually can remember or recall the fire curve or how it behaves on ignition, I have it in my next slides. So, there it is little different. Why? We will discuss that. But when we are doing any experiment, before putting into a building format, we need to do this standard fire test, and this is how we compare, and this is a independent material which is subject to fire, and if you see here there is a component delta theta at t time, and what is happening? The formula gives it is a logarithmic function of 8 times t, that is the time plus 1, and log of that into a component 345. So, it is the amount of heat. If you see, the thermal load of the material is being measured, and it is measured against a standard condition, which may not be as true as the actual situation. Now, this test has been done and this curve has been developed by our Indian Standards Organization 834, and we follow this, though it is not resembling or not a representative of a true fire. Let us move on to some important characteristics of a building material. What you see? Load bearing capacity, integrity, insulation. If you see the three bullets, load bearing capacity, integrity and insulation. In case of a fire, if it is a building, because our context is building, our building should not collapse. That means, we have lot of valuables, we have lot of occupants, we have lot of materials inside a building, and the building envelope should not collapse under the fire condition. So, that is very important point, and load bearing capacity is, even if there is a fire, my load bearing capacity of the material with which the building is made should resist collapse. Integrity. Integrity means the ability to resist the passage of flame and hot gases from one place to another. So, as you all are studying architecture expected or civil engineering, a space is defined by a wall, and from this room, if it is integrated, it should not pass to another room. So, the ability to resist the passage of flame or hot gases from one to another. Now, there are again several tests which is written in the statement, but we are looking into the integrity from the point of the building material. Third is the insulation, the ability to restrict the temperature rise on the exposed face. That means, the wall which is exposed to fire, like the fire is here. So, this should be having this material should be having the capability to insulate the fire, not to move to another direction, to the other side. So, this is side A, it should not go to side B. So, it should act as a wall, act as a barrier, as an insulator, and what is told, that the other side, that is the unexposed side, should not exceed 140 degree centigrade. So, even if it is subject to heat, it is getting heated, but the other side, on this side it may be 800 degree, 500 degree, but on the other side it should not exceed 140 degrees. That means, it should not lead to any other further burning. If it is, then it is not having proper insulation characteristics. So, we are doing these fire testings to test the building material against its load bearing capacity, integrity and insulation. Now, let us see, you see here in this picture, we are having three more curves, where the blue is the standard curve which we discussed, which is steady after 800 degree centigrade, just above 800 degree centigrade. Beyond that, you see it is a comparative thing. You see on top is a hydrocarbon graph. Below that, the green one is an external curve, which is for the facades, and a violet color curve, which is this one, you see that is a slow burning curve, like it burns slowly till say some time, and then gradually it increases. So, it is a gradual process, though you see after 20 minutes, 21 minutes, it has a different behavior. So, these are slow burning curves. Why we need to look into this? Because facade is maybe a different material. See, it is external curve, valid for assessing external facade walls against flames coming from opening in the fire compartment beneath. So, if your building is a multi-storied building, and if you have a fire here and some fire is leaking out from here, the facade gets damaged. The facade of the building might get damaged. So, here we need to understand understand the building material from this external curve. Whereas, the top one, the red one, which is not within our scope, which is mostly from the petroleum, offshore refineries, petrol stations, which is a very hydrocarbon curve where it is the ignition temperature goes up to 1000 degree and it is damaging within very short period of time. Okay. Coming to the slow burning curve, you see these curves are used for reactive materials, used either for fire protection of load bearing structures or for sealing of gaps. We will unfold it in our next slides. Okay. So, let us proceed further. Now, what is the limitation of the standard fire test? As I told you, the standard fire is a standard setup where the rise in temperature up to 800 degrees centigrade is very quick, and after that it is steadily increasing against a material. Now, and against that we test the other things. If you see the blue marked statements, the statements portions highlighted in blue, like in a standard temperature rises quickly and then increases indefinitely, but in practice we see it very differently, as I will come back to a slide from my previous lecture. You see the severity of fire in a compartment is also related to the fire load as well as the ventilation, like if the windows are open, if the window is closed, there are various ways of burning because of the oxygen limitations, because you need 16% oxygen in the atmosphere or in the air where the burning is happening. So, things may vary much from the standard fire test, but standard fire test is an index or a matrix. If it passes that, it will be okay, it will be below that in a practical situation. So, that is why we follow the standard fire test. Now, again you see fire in real building compartments do not usually occur in places with maximum severity at once, but when you are doing a standard fire test, it is happening immediately, the whole material is into fire, but in a building if it is happening, it may happen in parts. So, these are the various differences from a standard fire test and a practical situation where actually a fire has happened. Further is the wall thickness in real life has a different insulation capacity. So, thicker the walls, the insulation capacity will be different and severity in that case will be different. So, as you understand, the standard fire test is a guideline or a benchmark against which materials are independently or tested in isolation, whereas a practical happening may not be exactly the same what the conditions against the conditions a standard fire test is done. However, the standard fire test curve is very important to understand a building material and do a selection. So, based on that, the codes also do a material testing independently and give the results of a material based on that. Now, this is what I wanted to summarize from this standard versus the real fire or the practically when it is happening. So, as you see here, above 800 is that flashover period, whereas in this case this is also the flashover period which happens very gradually. In this case it is happening in a very short time. Here it is also happening, but the rise in temperature is very different. Here it is the full developed fire, this continues, whereas in case of a original fire or a real fire, it gradually decays, because if the fuel is exhausted, it will no longer burn. So, it will decay, though our standard fire test do not indicate the decay part, as if there is an indefinite supply of fuel. So, these things are very basic differences. However, the standard fire test is important metric for measuring a building materials heat liberation, which was given through the formula in the previous slide. Now, let us come to two very interesting indices which we need to know when we look into a material list where these are spelled out: flame spread index and smoke development index. Now, from my previous module till this lecture, I have never ever talked about the term smoke. So, with any fire there is a smoke coming out, and which is actually the unburnt fuel which gets into the air with its particles also, and they float in the air and has the buoyancy effect and moves upwards. We will have a complete lecture on how to tackle smoke, etc., because most of the fatalities are not because of fire, but because of smoke. So, understanding that, we also need to know a bed material may burn within small time without liberating any smoke. Then it may not have that same hazard or same effect to the mankind what if a material keeps on emitting toxic smokes. So, you are inhaling toxic smoke and you are actually choking your respiratory system. So, these are that is why smoke development index is also a very important metric parallel to the flame spread index. What is that flame spread index? It is determined by the distance that the flame travels along the test sample in a limited time. So, how it is done? You have to hang the material. You have to hang the material and set it to fire. The fire will move up, and how quickly it is spreading, that is the measure. And you see a reinforced cement board is rated as 0. So, if you hang a reinforced cement board and set it to fire, it will not have any flame spread. So, flame will remain limited to where it is, where it has started at the fuel point, and that is considered as 0. Whereas, red oak flooring, which is assigned an arbitrary rating of 100. So, it has been considered as it will burn, and its rate of burning is given a score of 100, and based on that, between 0 to 100 most of the materials are graded, and we have 3 such classes: class A, class B, class C. See, inorganic materials such as bricks and tiles. Now, I am coming to the our building materials, which is our within our purview or what we need to know. They are forming the class A materials, and its flame spread index is 0 to 25. That means, it will be almost as equal to reinforced cement board. That means, it will not spread the flame. The material is not a carrier of the flame to the next unit. Class B, whole wood material. You see, it has increased from 26 to 75, the flame spread index. So, it has a higher propensity to spread, and it is categorized under class B. And if you see class C, it is reconstituted wood. That means, formation of wood by assembling wood shaves like sawdust, like cork sheet, like straw boards. They are all reconstituted wood material, plywood. They are all coming under also our LDF, MDF, HDF, that is low density fiber board, high density fiber board, medium density fiber board. All these materials are having very high flame spread index, and it is double that the rating of the red oak flooring, which is given that value of 100. It is twice, up to more than twice of that. Now, coming to the smoke development index, there is a range of 0 to 450, and they may, in all the cases, it is the fuel which is burning, and it will go for a high range of 0 to 450 smoke development index. and they are similar. If they are on fire, their smoke will be of the same or similar index. Now, let us come to few instruments. There is a long list of instruments. I have given this for those who want to go further reading, do further studies with fire, they can get into the further details. But you see, the first three things are very important, that is the heat release rate. To test that, we use a cone calorimeter. For surface flammability, as we were talking of flame spread index in the previous slide, you can do a tunnel test, which is Steiner tunnel test, which is a surface flammability index. Particularly, these are important with recent developments of high rise structures, tall buildings, facades which are facade treatments which are made with aluminum panels with foam insulated. Their cases of fires are much higher, and that helps, that can be done, tests can be done using the Steiner tunnel testing, which is for the surface flammability. Heat release rate, we use a very standard cone calorimeter. Critical radiant flux, using the flooring radiant panel testing, that is for radiant heat, because one building may lead to radiant heat and burn the next building. There have been cases in Dubai, in the Middle East countries, where the radiant heat has led to another facade fire. So, these are very important, getting more and more important, and that is why you need to know further or get into little depth of what fire can do, what damage fire can do, and how we can actually restrict or resist, knowing the subject in a little deeper way. This is a cone calorimeter. If you happen to see somewhere, you must be able to identify. You can see here, there is this is the actual place where the ignition is happening, and this is the place where the readings are coming out, and you can get the results, and it is done on a very small sample. Now, what you can get from here? Time to sustained flaming and extinguished in seconds, heat release rate, average heat release rate, maximum average rate of heat, total heat release, mass loss, smoke production rate, smoke production amount. So, all these readings you can get from the panel when the ignition is done and the material is set to fire. I have a little closer view. These are developed from sketches. These are developed from internet after thoroughly knowing the thing. You see, that is that flame where, which is further elaborated here, that is the vertical way how it is oriented, how the material is kept, and then it is set to fire, and the smoke is going out, that is the exhaust or the blower that is taken outside the building, and this is how it is placed in that. So, this is the cone calorimeter aperture where the entire testing is done, and this you see gas analyzer including oxygen, carbon monoxide, carbon dioxide. So, these things are all inbuilt within the system, and you get the appropriate readings. Those who are doing researches on fire, they need to conduct the experiments, but we get ready some data from on the heat release rate of a material, the burning, the toxicity measures from the readings which are standardized and published in documents. So, based, as I told you, we need to know the grading, the fire grading of the material. So, if you see, in case of buildings, difficulties in extinguishing the fire when the material is burning, we have to look into, we have to categorize the material accordingly. Generation of heat energy when burning, that is the heat release rate. Difficulties in extinguishing means it is very difficult to extinguish the fire by external devices. Then is spontaneous combustion tendencies, lighting temperature flash point, it is continuously spontaneously it is catching the fire. Tendency to intensify the fire, tendency to expand the fire zone, that means it is spreading, the fire is spreading. Sometimes it is only the unit burning, sometimes it is spreading over the surface. It may have high inflammability, it may have explosive tendencies. So, we have to know building materials, we can restrict ourselves as I told you in the previous slide, that was integrity, load bearing capacity, integrity and insulation. Here you see the materials, this difficulty in extinguishing, that means if there is a fire, what will happen? You need to extinguish, you find difficult. Generation of heat energy, it is producing lot of heat which is burning effect. Spontaneous combustion tendencies means it is spontaneously burning and one leading to the other. Tendency to it is not controlled. Tendency to intensify the fire, that means it is adding fuel to the fire. Tendency to expand the fire zone. So, you have a small area affected with fire where maybe some action has to be taken, but it is gradually spreading out. Then it is high flammability and other is explosive, that means it may burst out like a bomb. So, materials are to be fire grading has to be should take care of all these points also. Building materials again based on those properties, that means the previously listed properties may be non-hazardous, hazardous and extra hazardous. Non-hazardous is not causing any damage if I consider all these points. You see which are the blue lines. They do not contribute to the growth of fire, that means spread of fire, growth of fire not affected. Who are they? Stones, bricks, concrete, metals, glass, clay products. Now, here is a important thing, metals. They are non-hazardous, but as you all know, since you all are having science background, metals are ductile in nature. So, it has a characteristic flaw when it is subjected to fire. So, that means it may change its shape, that is where the difficulty is, but it is not hazardous. So, if the material changes its shape, it may crumble down, it may break. So, that is where metals are to be taken care, but without metals we cannot have buildings, and that is why metals are inserted within, as you see, concrete, which is we call RCC, reinforced cement concrete. You all are in third year, fourth year, final year level. So, you all know what is concrete and what is RCC. So, within that the steel is embedded, not exposed, so that it is taken care, its ductility property is taken care. With heat it will become ductile. Hazardous are timber products, fiber board, straw board, PVC. I underline them again, they are all in blue. They produce huge quantities of heat, that means heat release rate is high, flame which can lead to spread of fire, and that means you cannot contain it within a portion. If you have another wooden material, it may immediately set to fire and it can increase the fire or the danger more. Other is extra hazardous. Here in buildings we do not use as a building material other than bitumen. I hope you all know, for the roof treatment we use bitumen. On the roads we have bitumen or asphalt which is called. that means the coal tar. So, you see it has very low flash point below 65 degree centigrade. So, it can lead to quick fire, because this temperature can be reached very quickly. So, one is bitumen, which we use in building industry for roofing or sealing purposes. However, the other things are the fabrics, cottons, paper, etc., which is not a building material, but which is inside the building. That means, if it is a domestic building, you have lot of clothes. If it is a laundry, if it is a hotel, in the laundry area there are lot of materials. In the hotel rooms there are mattresses which may be made of coir board, etc., which are wood shavings, or may be made of foam, which is a plastic, which is a polymer, and all these things are highly flammable. So, these extra hazardous items, though we do not use as a building material, but they form a part of the building component, which actually is measured by the fire load. In the previous class or the previous module, we have talked about FLED. Actually, fire load energy density increases with these kind of materials within a building, which gives you to the classification of buildings as per NBC. Depending on what is the use of the building, the fire load varies, and based on that the sanctions from fire department becomes more and more necessary or becomes mandatory for typical sets of buildings. If you go into the class of fire, we had gone into the materials, class A material, class B material, class C material. Class of fire, we usually in building context measure in time in minutes for resisting standard fire, which starts from 6 hours to 4 hours to 2 hours to 1 hour to half an hour. And we say it is a very qualitative measure, very high, high, medium, low, very low, and we grade them in the opposite direction. That means, very high means it is grade 1 and very low is grade 5. And the fire load in kilojoule per meter square is also given. So, these measures metrics we cannot go easily, because we always do not have the instruments, but we can take the time standard, time as a standard. So, usually buildings expected that it should be 2 hour fire rated. Some places it is 4 hours fire rated. So, we have to select materials, or we have to look into building materials which give you minimum of 2 hours fire protection, because within that time the building can be, the people can be evacuated out of the building, and also some properties can also be retrieved during that time, and the fire can be controlled. So, now here you see there are various listed materials as per our National Building Code 2016 and also prior to that, which are type 1, type 2, type 3, type 4, where you see in most of the cases for type 1 in building materials, what we see, fire separation less than 3.7 meter external walls, fire separation of 3.7 meter or more, but less than 9 meter of exterior walls, fire separation of 9 meter or more for exterior walls. These kind of type 1 fire ratings are type 1 buildings are type 1 fire resistance ratings are given. So, this is the type of construction required. Also, fire separation assemblies, fire enclosure or exit shafts for services, vertical separation, dwelling unit separation, all these areas you need such kind of fire rating, that means 2 hours fire rating. So, as a standard we go for 2 hours fire rating for most of the cases. the list is further elaborated. You can see here interior bearing walls, bearing partitions, columns, beams, girders, trusses other than the roof truss and other framings. They are all for type 1 buildings. It is 4-hour rated, 3-hour rated. For type 2 buildings or type 2 constructions, it is 2-hour rated. So, if you see, mostly it is 2 hours rated. Walls supporting structural members are 3-hour rated for type 1 building, type 1 construction. For type 2, it is 1.5 hour rating. Whenever you are going for the structural and the non-structural elements in minutes, these fire ratings are given in minutes, and depending on the type of construction, we usually go for type 2 constructions, and we have to maintain these we have to select our items which are of this rating, which we had given it here. Now, if we consider building materials, you see brick, stone. Brick is non-combustible, stone is non-combustible. It is bad conducting material, the other is also bad conducting material. Fairly fire resistant, stone is also fire resistant. They can withstand temperature up to 1300 degrees centigrade. Stone can bear temperature even more than that. Also, there are various stones which cannot take much amount of temperature, because stone is a naturally occurring material. Brick is a man-made material from clay with some additional mix to it. So, behavior of brick is more or less similar, but however, other than clay brick, we have fly ash brick. We have AAC now coming in, that is autoclaved aerated concrete, which is also used as a brick unit. Why I am telling? These are all our facade materials, our walls. Stones, we do not see a lot of stone buildings coming up in today's context, but flooring made of stone. We have to look into granite, we have to look into marble, that is which is a limestone, crumbles even at very low temperature and fire, because it is porous in nature. Sandstone, it is Kota stone is a sandstone which is abundantly used in public spaces, in public buildings. So, it is a very tough stone and which is very durable, but yes, it is also moderately behaving in fire. So, we have to keep these in mind when we are recommending understanding what is the use of the building. Concrete. Without concrete, for most of the buildings we have our floors, columns, beams made of concrete, which is non-combustible, bad conductor. However, it has embedded steel within it. It does not lose its strength on heating. So, when we talk of compartment, we understand that minimum the base and the top is made of concrete, which creates the compartment. Other 4 sides to create a compartment are the walls. So, loss of strength is negligible even up to 300 degrees centigrade, but gradually the strength decays if it goes beyond 900 degrees centigrade. By that time, it is expected that by certain measures the fire will be taken under control. So, concrete is a very important material so far as fire safety or building safety from fire is considered. Now, let us look into the metal part. You can see I sections, as you can see here in each picture, it has been taken as an example. Now, as I told you, metals get at 500 degree centigrade steel buckles. So, what is happening? It is not burning, but by material property it is D-shaped. it cannot remain as erect as it is. So, everything over it will fall. So, that is why you need to protect it or encase it. If you can encase it with some material which is fireproof, you can save the steel to grow in temperature and buckle. So, before the heat reaches the steel, you are trying to coat it with some material. One is solid protection. In case of rods, in RCC what we see, if this is a RCC column, we see there are rods, there is a stirrup, there are rods and they are all inside the concrete. So, these are all concrete within which the steel is there. But if it is an independent steel structure, if you can encase the steel with solid material, what can be that? It may be concrete. You can cover the profile, you see how you are saving on these portions, you are saving on materials on these portions, you are doing a profile protection. With what? With asbestos fibers, these are not much ignitable, and vermiculite and perlite, these are wastes from the volcanoes. So, you can actually use all these to encase the profile of the steel. You can also do something which is hollow. You can see these portions are the hollows. What you have done? It has been with extended metal lath. With expanded metal lath, it is covered, it is coated, and then on top of it some spray painting has been done. So, this is the air gap, and that is called the hollow protection with air gap, hollow protection with some infills. So, finally, your steel or the structural member is saved from any collapse. Since we cannot think beyond, we need steel in our construction and we cannot think buildings without steel, because it is the most robust tensile member used for buildings. We need to protect it from fire. If it is an exposed steel, we have to cover it up by these methods. Let us see some very important picture. This I had taken from a building which was under construction, and you can see the steel member. Here is the steel member which is coated with vermiculite paint. So, vermiculite spray. So, it is again, as I told, it is a hydrous cyclosilicate mineral which is usually, or which is vermiculite and perlite, these were volcanic wastes which are now prepared, and it creates a barrier on top of the steel, barrier between fire and the metal. The advantage of it is very lightweight, has air inside, trapped inside it, and it has very good insulation properties. Another kind of material which is important. So, all building, I am showing you only one column, the entire building, the I sections, this is the beam, the columns all are protected with, you can see this is another beam, this is the beam running, this is the cross beam, that is the column which is encased, and it is all, you can see the fire hydrant moving within the buildings, within the ceiling of the building. These are hanged from the top, that is the roof, that is the floor, and these are the vermiculite paint on top of it for the protection. Other ways of cooling a steel member. If it is a hollow section, we sometimes use hollow sections of steel, we sometimes use circular sections, sometimes use square bars, circular sections, say a truss. There, to keep the metal at a lower temperature, water is circulated. water can be circulated through it by mechanical devices or by gravity to keep the temperature lower than that, to save it from fire. The moment there is a fire, water starts circulating through these chambers, through these hollows, and it keeps running within these tubes. So, these are some also our pipes in building. If you can think of our pipes in building, which are our service lines, these are carriers of water, and it always is always at a lower temperature than that of the surrounding temperature, because it is always filled with water. So, non-circulating fixed or static water can be loaded inside this, can be embedded, can be injected within this by water circulation, or circulatory water cooling system can be there, continuously moving either by gravity or by mechanical pumping. These can keep the pipes or the steel elements at a lower temperature, so that fire cannot damage them. Other than that, what can be there? Screens of water. So, screens of water, like you may have a facade having windows, you can have a water jet continuously falling on it and not allowing the fire to heat the object. So, what is, so this is that window, and this is this water, and the fire cannot touch the glass or the steel member. So, that is what is placing screens of water, screens of partition between element and fire. So, we will see it later when we discuss in our next lectures. I have pictures for these, so we can look into that. Next is very interesting, which is intuminescent coatings. What does this mean? Intuminescent means it will protect it from fire. How? It increases in its dimension. Let us see. It is a paint which is put on the steel section. This is a enlarged, so entire area, if it is set on fire, if you can see this black area, what is it happening? It has expanded. The paint itself increases in dimension. How thin can it be? 0.25, that is a very thin coat, or it can be as thick as 5 millimeter. So, depending on how big the section is, you are putting a intuminescent paint coating. So, what is happening? On subjecting to fire, the paint layer will increase in volume up to 50 times. So, if your material is here, if it is having a coating, this coating will bulge out 50 times and the fire cannot reach the steel. So, this picture is explaining that, and being lightweight, these paints can be used on beams, columns, walls, ceilings, everywhere, even on wood surfaces, and you can protect your class B, class C materials by painting with intuminescent paint. Yes, it is a costly item, but yes, if it is having a fire, if it is it is saving life, it is important to use it. We have already talked about cellulose, which is all our building materials, all our materials within the building which are there, like as I told you, mattresses, like sofa, cushions, papers, documents, books. These all come under cellulosic fire. So, why is it being discussed? Because it is a very common material within residential and commercial buildings. So, they have a slow flame, and in comparison to others they spread very gradually, and flame temperature is 500 degree centigrade. But what is important, it takes very low time. In 5 minutes it will go up to 500 degree centigrade. So, if you have internal materials with steel or metals, if it reaches 500 degree centigrade quickly, it is very ductile in nature. By that time it starts bending and your building may be unsafe. So, you have to remember cellulosic fires inside a building and steel members, particularly steel, also other metallic members. Nowadays we have our windows of aluminum. So, as I showed you in the previous picture, it may be a window which is subject to fire, and you can save it by proper mechanism, proper screen on top of it, so that the fire does not damage it. Another two important processes, particularly with respect to wood: pyrolysis. What is that? Layer by layer burning. It also happens with stone. So, what happens in these cases? The breakdown of molecules only happens on the exposed surface. The exposed surface peels off, the next layer is exposed, it is again burnt. So, what happens? The strength of the material does not get lost immediately. So, layer by layer burning is called pyrolysis, and it is observed mostly in wood, also in stone. In presence of heat, a thermal decomposition happens that disintegrates cellulose in presence of oxygen, and the ignition of the wood starts if it cannot withstand that pyrolysis, or if the temperature goes beyond that pyrolysis temperature, gradually the ignition happens and the whole wood item gets set to fire. So, you see ignition temperature 233 degree centigrade for paper, wood has a little higher 370 degree centigrade. So, this cellulosic fire can initiate pyrolysis in internal wood items, in internal metal items, in internal rayon items, fabric items, it may be a curtain. So, these cellulosic one has to be very careful if any cellulosic fire happens inside the building. In most of the cases, cellulosic fire happens in residential and commercial buildings. Again, coming to how to protect it, surface treatment, that is, as I talked about, intuminescent paint. You see here, intuminescent paint of different colors can be put on the wood surface, and we can go for a fire protection of wood. But other is impregnation with monosodium phosphate, that means you inject a fireproof material within wood. What will happen? The fire will have pyrolysis on top of the surface, but it will never burn it, because you have impregnated it or injected monosodium phosphate, which is fire retardant. So, the flame will not spread on top of it. See, the cut edges will have same degree of protection as the surface. Damage to the surface will not hasten the flame spread. So, it will not burn the thing. So, ignition will not happen. So, these are some protections in case of wood as a cellulosic material, but as we use wood in our building, we need to treat them with intuminescent paint or have an internal injection of monosodium phosphate to keep it safe from fire. Other are the calcium silicate boards, gypsum plaster boards. What are these? These can encase, as we have talked about encasing steel, calcium silicate boards can encase any structural material. It may be duct covers, it may be fire doors, it may be cavity barriers. Gypsum plaster boards contains gypsum core, firmly bonded durable paper lining, and these gypsum boards can be used to cover up building material, can be used to cover up structural material, and it can protect from fire. In case of gypsum, gypsum is having 2 molecules of water with it, calcium sulphate with 2 molecules of water, and these 2 molecules of water vaporize very slowly, slowing down the spread of heat towards the unexposed side of the board. So, gypsum has its inherent water molecules saving it from the spread of high temperature to and protecting the material. Calcium silicate is a perlite, vermiculite perlite kind of material and helps to control the fire, and these are mostly used as encasing materials. Vermiculite board, perlite board already discussed. For steel, we can get it abundantly to these can be used to cover up surfaces to which can be exposed to fire or which has the tendency to getting exposed to fire, or materials which are highly or quickly ignitable can be saved by having coatings of vermiculite and perlite boards. So, as you have understood in the previous slides that fire safety coating material can be applied, this is a comparison table of the relative costs, its characteristics as well as the environmental impacts. Now, if you see it has been considered against a quantity of 1 to 0.1 to 0.2 kg per square feet of a coating and approximately 1 to 2 coatings that can give you a fire protection of half an hour to 2 hours, ranging to 3 hours also in certain cases. We have discussed intumescent paint coating, we have discussed vermiculite perlite, we have talked about cementitious coverings, that is encasing the reinforcement materials, that is steel members. So, you can see here are the list of the application areas, and here is the relative cost. You can consider it as moderate and high to low, where we find it is acrylic which is low, and yes, it has very not so much fire resistant in comparison with the other materials, whereas you can see vermiculite and perlite which we discussed at the end is cost is little less in cost, and also it is having a good fire safety fire protection capability. Coming to the environmental impact, it is the volatile organic compounds which are released to the environment. So, if you also consider that acrylic has low volatile organic compounds releasing to the environment. However, others have also usually they are low. You can see the first one, the intumescent paint, which is a very important application in steel members. Also you can see here at the vermiculite and perlite, which is also naturally occurring, and it does not have much of VOC content. So, with this I think we move on to the next slide, close this module with the understanding that we need to think before using a building material, and yes, the conventional building materials are always there, but the non-conventional materials or the alternative building materials which are coming, we should not jump and give a recommendation of a material without not considering its toxicity, its behavior in fire, and how it can have a damaging effect to the building as well as the inmates within the building. Thank you.